Hello everybody, I hope everyone is fine, and today we are going to discuss a question of analog electronics asked in GATE 2024 where a closed loop amplifier is shown here, and it has been mentioned that the open loop low frequency small signal voltage gain is 40. Since there are two terms, open loop and closed loop, let's first discuss about these terms. Here is a differential amplifier configured in open loop configuration where there are two inputs and one output. So this amplifier has a single-ended output where the inputs are differential. This input is non-inverting because if you apply an input here, this node will have a 180 degree out of phase signal, and then this node will have another 180 degree out of phase. So the output is in phase with this signal Vp. So that's why this input is called as non-inverting. Whereas this input Vn is inverting, as the input applied at Vn will produce a 180 degree out of phase output. And hence the output V0 is equal to AV multiplied with the difference between Vp and Vn, where AV is the open loop gain, since the amplifier is in open loop configuration. And this AV has a frequency response which is given as follows, where the gain reduces on increasing frequency beyond cutoff frequency. The cutoff means the 3 dB frequency, where AVO is the low frequency small signal voltage gain. And in the question, this AVO is given as 40, which means in dB it is equal to 32.04 dB, and at 3 dB frequency the value reduces by another 3 dB. We can replace the open loop differential amplifier with a symbol where open loop voltage gain is VO divided by Vp minus Vn. And in the question it is given that at a low frequency this open loop voltage gain is equal to 40. In the question it's given that the inverting input terminal Vn is connected to output. So we can say there is a negative feedback and it's a unity gain feedback. So the closed loop voltage gain is equal to VO divided by Vp is equal to ACL, which is the closed loop gain, is equal to AVO divided by 1 plus AVO. Remember, this is for the low frequency where the feedback factor is 1. So hence ACL is equal to 40 divided by 1 plus 40 is equal to 40 by 41 is equal to 0.9756, and option A is the closest one. Okay. Although the solution is so simple, but it's better to verify results with small signal analysis. This circuit has a differential output and this circuit has a single-ended output. In this circuit, if the inputs are differential, say Vp equal to plus del V by 2 and Vn is equal to minus del V by 2, then the node X is at AC ground. This can be justified as the circuit is symmetrical, and we have two identical networks connected like this, where this node is Vp, which is equal to plus del V by 2, and this node is Vn, which is equal to minus del V by 2, and this node is X. Then node X will be 0, that is ground. If we calculate the open loop voltage gain, then the small signal circuit is as follows, where in the question it is given that there is no channel length modulation. So RON is equal to infinite, ROP is also equal to infinite, and it is also said that all the transistors are biased in saturation. So the small signal analysis which we are doing here, that is valid. And it is also said that the current source is ideal. So the impedance across this current source, it is of infinite impedance. So if we calculate the open loop voltage gain, that is the single-ended output divided by the difference between the two differential input. Here the difference between these two differential input is del V. So if we calculate the open loop voltage gain, then it is minus Gm into the load value. Similarly, if we calculate the closed loop gain, when we apply an input of Vp, and let us assume that this node X is at a potential of del, then the gate to source voltage of this transistor, that is VGSN, is equal to Vp minus del, and this VGSN will induce a current in the upper PMOS, means the PMOS which is diode connected, and then because of this current there will be a voltage which will be induced, given as VGSP. And if we see the small signal equivalent diagram, we can see the VGSP is equal to minus Gm into VGSN divided by GMP, Okay, and this VGSP will induce another current in the right PMOS. That current will flow into the output. It is already given that RON and ROP are infinite. So if we see downwards, we can see that there is a diode connected NMOS, but we are not sure that whether the potential at node X, that is del, whether it is 0 or not. So for simplicity, we are assuming this as del, and you can see that there are two current sources. One is GM into VGSN and another one is which is coming from the GMP into VGSP. So we can see that two current sources are syncing at a point. So when two currents are syncing at a point, then that node has to be the lowest potential present in the entire IC. This total circuit, we can see that the lowest potential which is possible, that is 0. So our del is equal to 0. So if we calculate the closed loop voltage gain, then we will see that this is nothing but an unity gain buffer where the input is equal to the output. In the question, it is clearly mentioned that there is no channel length modulation. So because of which we cannot consider any of the output resistance. But if we are considering the output resistances, then we will get the actual value, which is 40 by 41. Else, if we do not consider the output resistance, then the closed loop gain will be only 1. Okay.